This is a fraction integer refresher to start off our Math 9 course. So a reminder that numerator is the number on the top of a fraction and denominator is the number on the bottom. We have a common denominator when the two numbers on the bottom are the same. And you need a common denominator whenever you're adding or subtracting fractions. So this first example here, they already have a common denominator, so it's pretty straightforward to add these together. All we have to do is add the numbers on the top. So we've got 4 plus 2, and they share this common denominator of 7. Then we just add those numbers together, so our final answer is 6 over 7. This example B is a little trickier because they don't start with a common denominator. We need to find one first, and then we need to manipulate or change the fractions such that they do have the same number on the bottom. So how can we make 6 and 4 be the same number? Well, if I multiply this whole fraction by 4 and this whole fraction by 6, we're going to get 4 over 24 plus 18 over 24. So that method is always going to work when finding a common denominator, is if you just multiply the opposite fraction by the other fraction's denominator. So this is 6, we multiply by 4. This one's 4, we multiply it by 6. That's going to work every time. The only thing though, is you're going to have more work to do at the end if you don't choose the lowest common denominator, because there is actually a lower denominator that we could have chosen here. So let's just go back a little bit. If instead we picked a different number, we know that both 6 and 4 go into 24. That's why that worked. But is there another smaller number that both 6 and 4 go into? And the answer is yes, there's 12. If we multiply this fraction by 2, the denominator is going to become 12. If we multiply this fraction by 3, then that denominator is going to become 12. And overall, we'll have less reducing to do. So then this new fraction is going to be 2 over 12. This new fraction is going to be 9 over 12. Now we have a common denominator. We can add them like normal, and we've got 11 over 12 as our final answer. A quick review of improper fraction versus mixed fraction. So improper is like this one here, and that's when the numerator is bigger than the denominator. A mixed fraction is when you have this large number out front and then a small fraction. These two numbers here are actually the same number. They have the same value. They're just represented differently, either improperly or with a mixed fraction. I actually tend to use improper fractions more. I don't really like the look of mixed fractions, but you'll see them sometimes, so you need to know how to use them. This is why these are the same. If we start with 15 over 4, this is the same as 4 over 4 plus 4 over 4 plus 4 over 4 plus 3 over 4. The reason that's true is because these all have a common denominator of 4, and if you added all of these numerators up, you would get 15. So we just split up the fraction into a couple other smaller fractions. And then we simplified because each of these, 4 over 4, or anything divided by itself, is just 1. So those all become 1 plus 1 plus 1. Then we're left with this 3 over 4 piece. And then this is why our final answer is we've got our big number 3, there's 3 whole numbers, and then just a 3/4 left over. So this example is about converting between mixed fractions and improper fractions. This first one is mixed because we have a mix of numbers. We have a big number and we have a fraction number. It's a mixed fraction. So to convert this to an improper fraction, the steps we take are, first, it's basically like the reverse of what we just did up here. So if we have 3 plus this 1/4, 3 is really the same. If we wanted to have a denominator of 4, this is going to be the same as 4 over 4 plus 4 over 4 plus 4 over 4. And we still have that original 1 over 4. Because this is just the same thing as 1 plus 1 plus 1, which of course would give us 3. And now we just add these fractions like normal. Since they all have a common denominator of 4, that's going to be the denominator. We add the numerators. 4 plus 4 plus 4 gives us 12, plus 1 gives us 13. So that's the improper version of this. Question B is the opposite. We're going from improper to mixed. So we do the reverse of what we just practiced. So we want to ask ourselves, how many 5s go into 17? Well, we'd have 5 over 5 plus 5 over 5. That gives us 10. This gives us 15, and we can't quite add another 5, so what we have remaining after 15 is just 2 over 5. So again, if we added those numerators, they add up to 17. This is the same as 1 plus 1 plus 1 plus 2 over 5. So then that's going to be 3 2/5. We also have multiplying fractions. So the steps to multiply fractions, we're going to first multiply the numerators, then we're going to multiply the denominators, and lastly, reduce to the lowest terms. So this is a lot more, it's a lot simpler than adding or subtracting fractions because you don't need a common denominator. So first we multiply the top, 3 by 2 is going to give us 6. Then we multiply the bottom, 5 by 6 is going to give us 30. We do have to reduce to lowest terms. How do we reduce a fraction? Well, do both of these numbers, like can we divide both of these numbers by the same thing? Yes, we can divide the top by 6 and we can divide the bottom by 6. That is going to give us 1 over 5, and then that cannot be reduced any further. Question B, we have mixed fractions, which is a little more complicated. So first we have to convert them to improper fractions, and then we can do our multiplication like normal. So converting these, if we got 2 1/2, this is the same thing as we've got 2 over 2 plus 2 over 2 plus 1 over 2. And that is going to give us 5 over 2. And we'll do the same with the other fraction. So we've got 3 over 3 plus 3 over 3 plus 3 over 3 plus 1 over 3, because that's 1 plus 1 plus 1 gives us this big number 3. And then when we add those numerators, we've got 3, 6, 9, so 10 over 3. So we converted them to improper fractions, and then we multiply like normal. This is going to give us 50 over 6. Can this be reduced any further? Yes, the top can be divided by 2. The bottom can be divided by 2. This will give us 25 over 3. And then 3 does not go into 25, so there's no further reduction that we can do here. Next, we've got dividing fractions. This is very similar to multiplying, but we have two things to do first. Dividing fractions, first you're going to flip the second fraction. So flip that fraction, so instead of 3 over 5, it's 5 over 3, and change the sign from division to multiplication. So you basically make it into a multiplication problem. And why does this work? Well, dividing by 2 is actually the same as multiplying by 1/2. We tested this out. If we took 10 divided by 2, that gives us 5. And 10 times 1/2 gives us 10 over 2, which also gives us 5. So we can practice up here. We're going to leave the first fraction the same. We're going to flip the second fraction and change the sign to multiplication. Now we just solve this like normal, multiply the top, multiply the bottom, and that cannot be reduced anymore. So there's our final answer. Lastly, we'll do a quick refresher on some integers. So an integer is a positive or negative whole number. Reminder, a whole number is basically a number that doesn't have any decimals in it. So we'll practice adding and multiplying and subtracting and dividing. First one, we've got 5 plus -8. Well, this is the same thing as 5 minus 8, because these cancel out, like the negative is going to override that. And 5 minus 8 is going to give us -3. And you can always look at this on a number line. If this is 0, this is +5. And then we're going to subtract 8 from it. So we'd go 1, 2, 3, 4, 5, 6, 7, 8. And that would have us at -3. Next problem, we've got -6 minus -2. So we can look at the number line again. This is 0. We've got -6 is here. We want to take away -2. There's a lot of negatives going on here, and it can be a little bit confusing. But what we did last time is these two signs are getting multiplied together. A negative times a negative gives us a positive. So this is actually the same thing as -6 plus 2. It's a double negative, which becomes positive. -6 plus 2 gives us -4. Again, looking at our number line, if we're at -6, we're taking away -2. So taking away -2 brings us up to -4. Taking away a negative makes something more positive. Almost done. Now we've got some multiplying. 2 times -5. Well, this is a positive 2 times a -5. A positive times a negative gives us a negative, because the negative is always going to override the positive. So overall, we've got a negative answer, and then we just multiply the integers. 2 times 5 is 10. So the answer is -10. Last one, we've got -12 divided by -6. Now we've got a negative and a negative. And remember, our double negative gives us a positive overall. So we can erase the negatives. Those are canceled out. And then we just divide the integers like normal. 12 divided by 6 just gives us 2. So your final answer would be +2. And there you go.